Uh, Over here, we look at three right angle effects for circle. So the first one is if we have a circle and then we have a diameter. Okay, so from the diameter we go out to form a, right triangle, and the other point is fall on the circumference, then it will be a right angle triangle. Okay, so as long as this one is a uh, diameter, then when it go to the circumference, we connect this one to the circumference, then for sure it is a right angle triangle. Okay, so diameter go out, right angle. This is the first fact. So the angle in a semicircle is a right angle. This has happened is because we know that the angle, the circum-angle and the angle at the center, their relationship is the center angle is 2 times the circum-angle. So you try to imagine for this one, when I move this point to somewhere here, okay, or I just move this one, this line. So I move this point, I move here, okay. This point, I move here to here. Then this is 180 degrees. And then this is the angle at the circums. Then it will be 80 degree divided by 2. Therefore, it is 90 degree. Okay. So we know that the center, okay, the angle in a semicircle is a right angle. This is the reason behind. Okay. Next, we look at the second property here. That is the perpendicular from the center of a circle to a chord bisect the chord. Okay, so this one is very important because later in many of the questions that we will discuss, we will use this property. And then the third one is the tangent to a circle at a point is perpendicular to the radius of the point. So this one, this is the tangent. So tangent, this is the tangent line. This is the tangent line. So the tangent line is perpendicular to the radius. Okay. So for this one, okay, actually, if we want to find the center of circle, I have a circle here. And then I want to find the center of the circle for this one. Okay, I have a circle, but I don't know where is the center. Then how to find the center is we just draw two straight line here. Okay, so after we draw two straight line, then we draw the perpendicular bisector. So this is the perpendicular bisector. So I don't have a compass here. If I have a compass, then I will put the compass here and then mark here and put the compass here, then mark here and here. This is the perpendicular bisector. And then this one also I draw the perpendicular bisector here. Okay, so perpendicular, and then this one also perpendicular. So this one actually I put here and then I draw here. Then the intersection between these two will be the center. Okay, so we have this property that if we have a radius, okay, so therefore we know that if we have a circle and this is a chord and the radius, okay, the radius will perpendicular bisect this chord. So this one, if the center is here, so the radius perpendicular bisect a chord. Okay, we must remember this fact that the perpendicular from the center of a circle to a chord bisect the chord. Okay, so we will use this in the following question. If we look at work example 5, a circle passes through the point PQ and have a radius of 5. Find the two possible equations for this circle. So over here, PQ won't be the diameter. Why PQ cannot be the diameter? Because if PQ is a diameter, then we have one possible only. Okay, and if I want to check the PQ is a diameter or not, I find the length of PQ. So the length of PQ is actually 7 minus negative 1 square plus the negative 5 minus negative 1 square. So what will we have will be the square root of 8 square plus the negative 4 square. Okay, so this one is the square root of 8 square plus 4 square, then it's 4 square root 5. So this is the 4 square root 5. And then half of this, when we have the PQ divided by 2, then we have the 4 square root 5 divided by 2 is 2 square root 5. So 2 square root 5, this 4 square root 5 is 8 point something. And then when we divide by 2, is 2 square root 5 is 4.47. It's not equal to 5. Therefore, PQ is not diameter. Okay. So over here, we know that diameter. Okay. Over here, we know that the radius is 5. So PQ. So therefore, PQ is what? So PQ is chord. So for this one, we find the perpendicular bisector of PQ. Okay, because we know that the perpendicular bisector, okay, this one, the perpendicular bisector of PQ will pass through the center. Okay, so over here, we just find the perpendicular bisector of PQ. So the midpoint of PQ is negative 1 plus 7 over 2 and negative 1 plus negative 5 over 2. So the midpoint is 3, negative 3. And then the gradient of PQ is actually negative 5 minus negative 1, 7 minus negative 1, then it's negative 4 over 8, that is negative 1 over 2. So the gradient for perpendicular bisector will be negative 1 over negative 1 over 2, then it is 2. So we know that the gradient is 2, and then the point that it passed through is 3, negative 3. So we have the y minus negative 3 equal to 2x minus 3. So we have the 2x minus 6. Then we have the y. This is plus 3 and then move to the other side, then will become minus. So we have the y equal to 2x minus 9. Okay. So we know that this one will pass the center AB. So we have x equal to a, y equal to b. Okay. Then we have the b equal to 2a minus 9. So this is the first equation. So we have the point P and point Q here. And this is the perpendicular bisector of the PQ. So the circle, the center of the circle will fall on the perpendicular bisector of AB. Then next, okay, we know that the center is AB. So the center is AB and the radius is pi. Then we have x minus a squared plus y minus b squared equal to phi squared. So we have the x minus a squared plus y minus b squared equal to 25. So it's passed to the point P and Q. Then I take either one. I found that P is easier. So we have the is passed through the -1, -1. So when x is -1, y is -1, we sub into this equation. Then we have -1 minus a squared plus -1 minus b squared equal to 25. So this is the second equation. We sub the first equation in the second equation. So we sub 1 into 2. Then we have the -1 minus a squared plus -1 minus 2a minus 9 squared equal to 25. Then this one is -1 minus a squared plus -1 minus 2a plus 9 squared equal to 25. So it's -1 minus a squared plus the 8 minus 2a squared equal to 25. Then we expand this one. We have 1 plus 2a plus a squared plus 64 minus 32a plus 4a squared minus 25 equal to 0. So we know that the -1 negative a squared, when both item is negative, then this one is actually equal to the 1 plus a squared is equal to both item is positive. So this is 1 plus a squared. Why? Because I have the -1 multiplied with 1 plus a. I factorize the -1. Then it will become -1 squared, 1 plus a squared. Then this one will become 1. So it is 1 plus a squared. So I can just write 1 plus 2a plus a squared. Then it will become 5a squared minus 30a and then plus 40 equal to 0. Then we have a squared minus 6a plus 8 equal to 0. Okay, so over here, we do the factorization. Then we have the a 2, 4 minus minus. Then we have a equal to 2, a equal to 4. So we can sub the a equal to 2 and a equal to 4 to the equation number 1. So we can sub this one. Okay, so we sub a equal to 2 into equation 1, then b equal to 2, 2 minus 9, 4 minus 9, then it is -5, and we sub a equal to 4 into equation 1, b will be 2 times 4 minus 9, then it is -1. So this is 2, -5 is the center, radius is pi. This one is 4, -1 is the center, and then radius equal to 5. Then the equation will be x minus 2 squared plus y plus 5 squared equal to 25. And x minus 4 squared plus y plus 1 squared equal to 25. Okay, so actually this one is we have the x minus 2 squared plus the y minus -5 squared equal to 5 square. And x minus 4 square plus the y minus negative 1 square equal to the 5 square. So we have these two equations, x minus 2, 2 negative 5, 5, 2 negative 5, 5. So we have this one, x minus 2 square plus the y plus 5 square equal to 25. Hey, you see, this circle pass to both P and Q point here. And then we have the 4 negative 1. Okay, so 4 negative 1, 4 negative 1. So we have the x minus 4 square plus the y plus 1 square equal to 25. So this one also pass to these 2 points here, P and Q. So this is the equation. Okay.